All right, last type of conic we're going to cover is called a parabola, which sounds very, very familiar. Difference being now is that parabolas are allowed to open to the left or right because we're not defining functions here. A conic section is not a function. So standard forms of a parabola, here's all your information regarding those. So we are starting with parabolas centered at the origin. So they do have a vertex, so we know what a vertex is. It's either the bottom or top of a parabola opening upward or downward, or the leftmost or rightmost side of that parabola if it opens side to side. So every parabola still has a focus. It also has something called a directrix. The line for the directrix and the point of the focus, every point on your parabola is equidistant from those two things. So if we found the distance from the focus to any point on the parabola, it would be the exact same as the distance from that same point to the directrix. All right, find the focus and directrix of the parabola given by the equation y squared equals 8x. So first thing we want to do is just look at the standard form of an equation. Standard form of an equation for this parabola is y squared equals 4px. So if we compare that to what we were given y squared equals 8x. We know that 8 has to equal 4p, or 4p equals 8, whichever way you want to write it. If 4p equals 8, well, then we can just go through and solve for p, divide both sides by 4, and we get that p equals 2. So if p is 2, we know that the distance from the focus to the vertex has to be the exact same. So this parabola, we need to know which direction it opens, because the y squared is, if the y is being squared, we know it's opening left or right. Because p is positive 2, so we know p is greater than 0, we know it's going to open to the right side. If p is less than 0, it would open left. If p was less than 0, it would open down. So we know it opens right. So what that tells us is that our focus is inside our vertex of 0, 0. So that means we would go right 2 units to get to the focus from our vertex of 0, 0. So our focus is going to be the point 2, 0. The directrix, the equation of the directrix in this case, if it helps, just give yourself a very rough visual. So there is my very rough sideways, well, almost, I want it to be pretty. Third try is a charm. Nope, one more. All right, I give up. So there is my right side open parabola. So my focus has to be inside of that vertex, which means the equation of my directrix is going to be outside, but the same number of units. So the equation of that directrix is going to be x equals negative p to get it to go the opposite side. So our directrix is x equals negative p, which would be negative 2. So the equation x equals negative 2 is where our directrix is located. All right, next definition, the latus rectum. This is a line segment, keyword being segment, which means it's got endpoints that goes through the focus and is parallel to the directrix. So it's like a chunk of a line parallel to the equation of the directrix. Okay. All right, find the standard form of the equation of a parabola with focus 8, 0 and directrix at x equals negative 8. So I'm going to go ahead and try to figure out my equation here. So based on the focus being at the point 8, 0 and the directrix being a vertical line, I do know that this is a sideways opening parabola. So if I again do a rough sketch, focus 8, 0. So again, I'm going to put a coordinate on this one because I need to get everything lined up. So focus is a singular point 8, 0. Directrix x equals negative 8, equation of a line. That tells me right there which way my parabola opens. Well, my parabola has to open to the right because the focus needs to be on the inside and the directrix needs to be on the outside. So very terrible drawing, but it still gets us the same idea even if it is a terrible drawing. So that tells us the equation is y squared equals 4px. All right, remember P tells you how far to go inside to get to the focus and outside to get to the directrix. So if we went inside 8 and outside 8, we know that P equals 8. Because it opens to the right. If it would have opened left, it would have been negative 8. So if it opens left or down, P is a negative value. So if P is 8, we get the equation y squared equals 4 times 8x, and 4 times 8 is 32. So y squared equals 32x is our equation. All right, shifting the parabolas off the origin, just like we did with the other conic sections. And so here's your information for organizing that. Again, it's just a matter of knowing the horizontal or vertical direction of opening, and then only changing, if it's horizontal, only changing that x value to get right inside your focus or left for your directrix, or vice versa if it opens to the other way. And then only changing the y value if it is a vertical parabola. All right, given x minus 2 quantity squared equals 4 times the quantity y plus 1, find all the following. So first thing we're looking for is the vertex. Same thing applies as before. Minus right plus left. So vertex, x value, we have x minus 2, so that means we are going right 2 units. And then we have y plus 1, so we are going down 1 unit. So the vertex is going to be 2, negative 1. To get the focus, we're going to need to locate P and the direction at which it opens. So first thing is P. P is going to be associated with the number outside multiplied on the side not being squared. So 4 is the simplified form of 4P. So we know that 4P has to be 4, therefore P is 1. So looking at the form of this parabola, P is positive, so it either opens up or it opens right. X is being squared. When x is being squared, it's a vertical parabola, so we know it's opening upward. So we have an upward parabola. So we are asked to sketch a graph. I like to kind of do it all together because to me it just works a little bit better in my head to have a visual to look at. So I want to go ahead and mark my vertex of 2, negative 1. Actually, I'll scoochie this up a little bit. So 2. That's crooked. Negative 1. All right, here's my vertex, and I know it's opening upward, so that can help me identify my focus. So I know my focus is P units inside of that vertex. So here's my 2, negative 1. So if I go P units inside, I've got to change the y value of the focus. So I'm going to add P to the y value. So that's going to give us 2, comma. If I add 1 to negative 1, I get 0. So our focus is going to be located at the point 2, comma 0. So I'm going to change colors. I'm going to do it in green. So 2, comma 0. So here is our focus. Equation of the directrix. The directrix is P units below. So it's going to be y equals, because it's got to be a horizontal line. Now we go P units below the y value of the vertex. So we're going to go 1 unit below negative 1, which is going to put us at negative 2. So if I draw my directrix in, negative 2, try to keep them equidistant, which means I'm going to move this down some. About there. And that's a dashed line. So we could find some more points if we wanted to plot our parabola correctly. So like we could plug in 0 for y and solve for x, but we know what way this thing's going to open. We've done all those nitpicky details before. So then we just get our parabola swinging in here. Something like this. It's a little large, but I think that's all right. All right. Example 4, write the equation of the parabola in standard form. So just like we did with all the others, we're going to look at our parabola. So difference with this from the others is completing the square only has to be done once because only one term is being squared. So if we look at this equation, x squared plus 8x, the x is being squared, so that means I want to move everything without an x to the opposite side. So I've got the x squared plus 8x. I'm going to leave some room to complete the square. We're going to add 4y to both sides, and we're going to subtract 8 from both sides. All right, no, I got my plus blank and my plus blanks. Remember, we got to add something to both sides. Nothing's attached to the x squared, so don't have to worry about factoring anything off in this case. So just the coefficient of x, 8, divided by 2, quantity squared on both sides, 8 over 2, quantity squared. So that's going to give us x squared plus 8x, 8 over 2, 4 squared, 16, equals 4y minus 8 plus 16. All right, factor the right. That is x plus 4 quantity squared. Combine on the left. Negative 8 plus 16 is positive 8. And then to get it to the true standard form, you're not allowed to leave anything attached to y because remember that's standard form to help you find p. So x plus 4 quantity squared equals 4 times the quantity y plus 2. So there's a standard form of our parabola. All right, example 5. An engineer is designing a flashlight using a parabolic reflecting mirror and a light source. The casting has a diameter of 6 inches and a depth of 4 inches. What is the equation of the parabola used to shape the mirror? At what point should the light source be placed relative to the mirror's vertex? So same as when we dealt with the others, sketch it and put the center, or in this case, the vertex at the origin 0, 0. And flashlight, let's just keep it simple. I want this thing to open upward. All right, so here is my... I don't really need to go below because our equation is, whoops, here, whoops. There we go. All right, so there's a vertex. All right, it says the diameter is 6 inches, so that means up here at the top, that's going to be 6 inches, so that means it's going 3 either direction. So we're going to go 3 to the left, 3 to the right, because the total's got to be 6. Here's our parabola. Maybe. All right, there's our parabola. And then it's got a depth of 4 inches, so that's going to be, this distance right here is going to be 4. Dashes again. So what that tells us, we could use either one of these points. I would rather use the positive than the negative. So this point on our parabola, we know is the point 3, 4. All right, I have a graph now. Let's see, what are we trying to find? The equation. All right, so to get the equation, first thing, right form, this is a vertical parabola opening upward. So I know the standard form of the equation is going to be x squared equals 4py. All right, so we have 3 variables in the standard form. We know the point 3, 4 is on this parabola. If I plug in for x and y, the only variable left is p, so then I can back solve for p. So we know that 3 squared is going to be equal to 4 times p times the y value, 4. So 9 has to be equal to 16p. If we divide both sides by 16, we get that p is 9/16. So standard form for our equation is going to be x squared equals 4 times 9/16 y. And if we simplify that, it would be 9/4 y. Actually, you know what? Let me go down to the next line. Here, we're going to scoochie this up, shrink it down. There we go. Now I can make it fit. So x squared equals 9/4 y. So there's our equation. So that's one thing we were asked. Second thing we were asked, zoom out. At what point should the light source be placed relative to the mirror's vertex? So relative to the mirror's vertex, what that means is we need to make sure it's equidistant so that it does reflect properly. So that means we need a point inside of our parabola, and that's where your focus comes in. So what we're going to place the light source at right here. That way it does mirror properly onto that parabola. So the light source should be placed at, that is going up p units from the vertex 0, 0. So it should be placed 9/16 of an inch, speaking in context, above the vertex. So we'll say p inches above the vertex. And since p is 9/16, we're going to place it 9/16 of an inch above that, I guess you could say above the bottom of the casting. Because the flashlight technically doesn't have a vertex, it has that casting shell, which we're going to place it at the bottom of it. All right. So last thing you've got to be able to do is figure out the equation of the conic, or the type of conic section given when the equation is not in standard form. So meaning everything's all jumbled together. So you have some options here. You can do this the hard way, where you go through the completing the square process and then recognize the characteristics, or you can do this the easy way by just pulling out those little details that are going to determine whether there is subtraction involved, whether it's equidistant, whether it's different distances, etc. So the way the text has you do this is just recognizing, finding the coefficients of the squared terms, and then just comparing them to each other or comparing their product. I do it a little bit differently, so I've listed your rules. If you want to use the a as the value of x squared and b as the value of y squared, and then find these four things to figure out which one fits, you can. I think it's a little bit easier to just look at it in general and go through it. So I'm going to do it a little bit differently than comparing a with b. All right, so we're just identifying. We don't need to write them in standard form. We are just saying, is it a circle, is it an ellipse, is it a parabola, or is it a hyperbola? So if we look at a, the equation for a has both x squared and y squared. When both x squared and when both x and y are squared, it is either a circle or it is an ellipse. Okay. Difference being, so they are being added. So then we look at the coefficients. Because they're being added, we're down to 2, circle or ellipse. And then, that's not a highlighter, we just look at the values. The coefficients of, I'll get a highlighter in just a second, x squared and y squared are different. That means the widths are different from the center. An ellipse has different widths. So this is the equation of an ellipse. All right, B. So I'm also dealing with a sum, so I know it's either a circle or an ellipse. I look at the coefficients of x and y, or coefficients of x squared and y squared. They are the exact same. That means the distances are equal. Well, the distances are equal on a circle because it's completely round. It's not oblong or oval shaped. All right, C. C only has y squared. When only one of the two variables is squared, it's a parabola. And lastly, both x and y are squared. However, subtraction is involved, so it's got to be a hyperbola. Hyperbola is the only one that squares both and involves subtraction. So we got a hyperbola. And that is the end of your conic sections.